This conference will now be recorded.
Yeah. So once again, good morning, everyone. So today we are going to start with lecture 5, which is on pre-stressed concrete structures. So let me revise the content which we delivered in the previous class. So we gone through different types of methods, systems of pre-stressing technology. So which is having a lot of advantages towards latest engineering techniques. So we deal with what are the different types of pre-stressing in terms of operation. So there is a hydraulic pre-stressing, there is a mechanical pre-stressing, and there is a thermo-electrical pre-stressing. Okay, so that is the mode of doing stressing, right? So along with that, we discussed the way how the pre-stressing can be done based on the structural element, right? So there will be like linear pre-stressing where the members are longitudinal, right? So where the members are linear, so by that we can go for linear pre-stressing. So if the member is something like a curved shape, so we go for a curved pre-stressing. Okay, so that's how based on the shape of the structure, based on the shape of the element, so we go for linear pre-stressing and curved pre-stressing. Okay, so and again based on the type of element. Okay, so based on the application and based on the application of the load, I can call it as. So in that way, the pre-stressing was classified into 3 categories. One is a uni-axial pre-stressing. The best example for uni-axial pre-stressing is beams, right? And multi-axial, sorry, biaxial pre-stressing. So we do biaxial pre-stressing for slabs, right? And third one is multi-axial pre-stressing. So we go for 3D structural elements like domes and all. So domes, it's like 3D structure. So where we go for multi-axial pre-stressing for that. Okay. So that is how the pre-stressing was classified in the way of application of the load, right? And what else we discussed? Yeah, so and again stressing was classified into pre-tensioning and post-tensioning, right? So pre-tensioning we go for bulk quantities where we are going to generate in terms of small units. For a small units we go for pre-tensioning like railway sleepers, electrical poles, concrete electrical poles, partition walls and all. Okay, and these are the example, best examples. And there is the post tensioning, so which will be happen for heavy structures like girders, bridges and box girders. So these are the heavy structures where they are supposed to be carried with post tensioning, right? So in that way we discussed different types of pre-stressing systems and all. Along with that, what are the stages of pre-tensioning? There starts from anchoraging the rods, pouring the concrete after getting set, and how you are doing the stressing and all. So what are the stages of pre-tensioning and what are the devices used in pre-tensioning? That all we discussed in the previous class. In the same way, what are the stages there in the post-tensioning, right? And the same way, what are the devices used for post-tensioning also we discussed in the previous class, right? So these are very, very important. When you go for interview, they're gonna question at least 1 or 2 out of these concepts which we discussed in the previous class, right? So that's how the lecture 4 gone with. And today we are going to discuss mainly on the materials which are going to be used for pre-stressing, right? So pre-stressing in the sense they are not just pre-stressing materials. Along with that, there should be a concrete, there should be a steel, and there should be a pre-stressed materials which are supposed to be used to go for pre-stressing technology or pre-stressing system, right? So let me start with the materials. The first one is concrete, right? So first because concrete is a major composite material, so where we are doing stressing, I mean where we are inducing or inducing compression stresses into the concrete. That's how the pre-stressing we are inducing to the concrete, because that is one of the important element where we are doing this pre-stressing for that, right? So here, as we know, concrete is a composite material, so which is a combination of materials like cement, aggregate, water, and other kind of admixtures which are added into it, right? So like aggregate in the sense there will be a coarse aggregate, there will be a fine aggregate, right? So this is what we are expecting students to learn, and students should be familiar with the basics of concrete technology, right? If you're not having good basics towards concrete technology, there is no point to go with the concepts of where we are particularly doing for concrete. Yeah, so let's discuss individual materials there in concrete. So we'll go with the aggregate. So as we know, coarse aggregates are something like a granular materials, so which we are going to obtain from from igneous rock, right? So like a crushed stone. So this is how we are going to get the aggregates. So when the aggregates are something like which we are getting from different rock or different stones. So based on the sizes, they are classified into coarse aggregate and fine aggregate. So nowadays, robo sand is also getting from the crushed stone. When we are crushing into a fine powder, we are calling it as a dust, right? So that itself they are using in a form of a fine aggregate into the concrete nowadays. Okay, so not only that, there are many other aggregate materials which can make concrete into light in weight. Okay, so as we all know, granite is a material so which we are using for as a coarse aggregate. Along with that, slag, shale, fly ash, and clay for use in lightweight concrete. These are also coarse aggregates which we are going to use in concrete to make concrete light in weight. Okay, and along with that aggregate, coming to fine aggregate. So we regularly use the sand which is obtained from riverbeds, or quarries. So which we are calling it as robo sand. So which are going to be used as a fine aggregate, right? So here the fine aggregate is along with the hydrated cement paste, so which is going to fill the space between the coarse aggregate. Okay. So by that I can say aggregate is going to be used as a pillar material in the concrete. Okay. See, whenever you go to interviews, they're gonna ask you. So in concrete, what is the purpose of cement? Tell me what is the purpose of cement? Cement is acting as a binding material. Okay, for binding, acting as a binder material. Then what is the purpose of aggregate? Aggregate is acting as a filler material. Okay, so to fill the voids, to fill the gap between the concrete. So that's how within the concrete, that's how we are using fine aggregate as a filler material. Okay, so that's how aggregate is having a vital role towards imparting strength to the concrete. Okay, and next one, coming to the size. Okay, so I think you all familiar with IS 456-2000, which gives you what should be the maximum coarse aggregate size, so which is going to be used in RCC, isn't it? So can anyone answer me what is the maximum coarse aggregate size which you are going to use in reinforced concrete structures, RCC? Can anyone please answer to my question, or you can just text me? What is the maximum coarse aggregate size which you are going to use in your RCC? Please, you can unmute yourself and you can answer to my question. 20 mm, is that right? 20 mm, and they will go with the combination like 12.5 mm. Yeah, so that is 10 mm. So these are and coming to the maximum coarse aggregate size, it will be 20 mm. They won't go beyond 20 mm. Okay, in RCC particularly. But coming to especially here in prestressed concrete, the nominal maximum coarse aggregate size you are going to limited with these three following quantities. Okay, so what are the first one? 1/4 times the minimum thickness of the member. Okay, 1/4 times the minimum thickness of the member means what? So let us take a beam, right? So what is the minimum dimension of the beam? It will be the width, right? Depth will be more than the width, length will be more than the width. By that, width will be the minimum dimension. So in that minimum dimension, you have to go with 1/4 time the minimum thickness of the member. Minimum thickness in the sense width and matter. Okay, so let us take a long beam of length 1 meter, depth half meter, I mean 500 mm, width 300 mm. Okay, can you tell me what is 1/4 of 300 mm? So like that you have to decide. I'm just telling example amount. Okay, so in that way you have to decide the maximum coarse aggregate size based on the first condition, which is 1/4 time the minimum thickness of that particular element. Okay, second one, spacing between the strands or tendons minus 5 mm. Okay, so let us take the group of strands, we call it as a tendon, avuna, right? So I think you all know what do you mean tendon. Group of strands is called a tendon, right? So group of strands in the sense, so the spacing between one strand to other strand, so the spacing between these two strands, it should be, sorry, it will be something like, some, for example, 30 or 40 mm. Okay, so your course aggregate should be minus of that space. Let us take the space between two strands is around 30 mm. Okay, so what should be the aggregate size which you are going to use in that particular concrete? 30 minus 5, it should be 25 mm. Okay, so like that you have to decide the size of the course aggregate based on the second condition. What is the third one? 40 mm. Usually we go with the 40 mm in the course aggregate in the concrete. Okay, so like this you have to go with minimum out of these three. Okay, so that is what the condition. The nominal maximum course aggregate size is the lowest of the following quantities. First you have to check 1/4 times the minimum thickness, what is the size? Spacing between the tendons or strands minus 5 mm, what is the size? And 40 mm. Out of these three you have to go with the minimum size. So that will be your maximum course aggregate, not the minimum. Okay, these three will use the minimum value. That minimum will be the nominal maximum course aggregate size. Okay, so that is how you have to decide the nominal maximum course aggregate size. Okay, I hope you all understand how you to decide the nominal maximum course aggregate size. Okay, next. So next, coming to the cement. So as I told you, cement is nothing but a binder material. Okay, so which is going to be added into the concrete to bind the coarse and fine aggregate, right? So here, as we know, it is a mixture of limestone and clay, so which is going to be heated in a kiln of temperature around 400 degrees to 1600 degrees centigrade, isn't it? So that is how the cement is going to be used in concrete, right? So this is one of the important competitive question number. Okay, what is the maximum temperature of cement which is going to be heated in a kiln? 1400 to 1600 degrees centigrade. Okay, please try to remember that. And next, coming to water. So water is also one of the additive in concrete, right? So water which you are going to use for mixing, and not only for mixing, even after casting you are going to cure your element in water, right? And curing, it should be very clean and free from other foreign bodies. Okay, so like injurious amounts of oils undakodu, it should not have any kind of acids, alkalis, salt, sugar, organic materials, and other kind of substances. It should be away from all these other kind of foreign materials and matter. Okay, so that kind of water you are supposed to be used for casting concrete, right? And next, coming to the admixtures, as I told you, along with cement, quartz aggregate, and water, there is another important material which you are going to be used in high grade concretes. Okay, as I already told you, in prestressed concrete we are going to use high grade concrete and high grade steel. To achieve high grades, without admixture you can't achieve high grades. Okay, understand? Without admixtures you can't achieve high grades. Why? Let me tell you. See, can you answer me? When grade goes on increasing, what happens to water cement ratio? What happens to water cement ratio when grade goes on increasing? Water cement ratio will get decreases, isn't it? When grade goes on increasing, what happens to cement content? Can you tell me what happens to cement content when grade goes on increasing? Cement content will increase. Okay, so grade goes on increasing, water cement ratio decreases, workability will decrease. When workability will decrease, strength decreases. Then how can you achieve high strength concrete? You can't. Let's take M25. Okay, what is the water cement ratio? What is M20 water cement ratio? So when grade goes on increasing, your water cement ratio will decreases from 0.3 to 0.25 like that. Okay, so then if you go M40, M50, it will become like 0.1 or 0.2. So which is very tough to get good workable concrete with that water cement ratio. So then what we do to increase the workability, okay, to increase the strength of the concrete, you are supposed to use admixtures. Okay, so high strength concretes, high grades concretes will achieve its maximum compression strength only based on the admixtures. So that is how admixtures plays a vital role in terms of workability, in terms of durability, in terms of shrinkage, in terms of strength. Okay, so that's how the admixtures are going to be used, and they are going to be broadly divided into two main categories. One is chemical admixtures, other one is mineral admixtures. Okay, let's talk about what are the chemical admixtures which are going to be used in concrete to make concrete workable, to make concrete high strength, to make concrete durable, to make concrete less impermeable like that. Okay, so first one is air entraining admixture, water reducing admixtures, self retarding admixtures, set accelerating admixtures, water reducing and set retarding admixtures, plasticizers, super plasticizers, hyper super plasticizers, right? So accelerating admixtures, retarding admixtures. So like that, you are having different types of chemical admixtures which are going to be used based on the need. Okay, based on the at that particular instant what kind of admixtures you need. So based on that, you're going to use. Okay, so that's how admixtures are very, very important. Okay, please try to remember that. So without admixtures, you can't achieve the high grade concrete. Okay, right. Next one, mineral admixtures. What are the mineral admixtures which are going to be used which replace cement? Okay, so here you must know one important point. Chemical admixtures, you are not going to replace any material. Chemical admixtures are going to be added with the percentage of cement. Okay, so let us take let us take M30 grade of concrete. While mixing the chemicals into the concrete, you are not going to replace anything. You are going to add that admixture, chemical admixture, into that concrete, which is the percentage of cement. Understand? So that is how the chemical admixtures are going to be added into the concrete, right? And next one, mineral admixtures. So mineral admixtures are the one who are going to replace the materials. Okay, what material? Here you are going to replace cement. Okay, why? Because as I told you, high grade concretes will have high quantity of cement. When you add more quantity of cement, what happens is that cement is less in cost? No. When more quantity of cement, obviously the cost of that concrete is going to be increased. To reduce the concrete, you have to reduce the cement content. Okay, how to reduce the cement content? You have to go with the alternatives of cement materials. Okay, in that way you can able to replace the cement with some kind of mineral admixtures. Okay, that is what happening, adding of mineral admixtures into concrete to achieve high strength without increasing the cost. Understand? So that is what the common mineral admixtures which are going to be used. So let's talk about what are the mineral admixtures available and which are going to be used for prestressed concrete to achieve high strength. Okay, one is fly ash. You all know fly ash is a byproduct of thermal power plants, right? Next one, ground granulated blast furnace slag, GGBS under, right? So GGBS is the byproduct of steel industry. Okay, byproduct of all kind of furnace industries, right? So steel industry నుంచి వచ్చిన last byproduct waste material, so we are calling it as a GGBS. That's why it is called as a slag. That slag, it might be either from steel industry or aluminum industry or copper industry or brass industry, whatever alloy industries. Okay, whatever the slag we get from the blast furnace, our furnace నుంచి వచ్చిన waste material we call it as a ground granulated blast furnace slag. Okay, third one is silica fume. Silica fume is one of the mineral admixtures which you are going to get as a waste product from glass industries. Okay, glass industries నుంచి వచ్చే waste material we call it as a silica fume. So we are making use of that waste to replace cement. Why? Because all these mineral admixtures are having what cement have. Cement ki etuvanti chemical properties unnayo, the same chemical properties that mineral admixtures also have. Understand? So that is the reason why we are replacing cement with the mineral admixtures which are having the same mechanical properties, right? So please try to understand, whenever material having a good chemical property, it leads to good mechanical property. Okay, if the material is having bad chemical composition or bad chemical properties, it won't have good mechanical property. Okay, why? Because mechanical property is always depends on chemical composition. Okay, it depends on chemical properties, right? So that is how replacing cement with the mineral admixtures, it should match with few chemical properties. Okay, chemical composition, otherwise you can't make use of them where you can replace the cement, right? Like next one is rice husk ash. So rice husk ash is something like waste product from rice husk. Okay, Telugulo మనం పొట్టు అంటాం కదా. So that is a waste byproduct from rice husk ash. Then next one is metakaolin. So metakaolin is also one of mineral admixtures where you can replace with cement. Okay, so this is how the mineral admixtures are going to be used to replace cement and to achieve the high grade concrete for the pre-stressed concrete structures. And next one, properties of hardened concrete. So this is very important. Why? Because in pre-stressed concrete we are going to use the hardened concrete. Okay, where concrete should have high strength, where concrete should have high durable, right? And concrete should have high stiffness. What do you mean stiffness? So stiffness is nothing but load per unit displacement, right? So that is how it should have. It should have a carrying capacity where it have very less deflection towards the load. So that is how the hardened concrete which you are going to use in terms of high grade, it should have high strength, it should have high durability, it should have high stiffness and minimum shrinkage and creep. Okay, as I told you, why we are using high grade concrete? Why? Because high grade concrete will have very minimum shrinkage, very minimum creep. Okay, so that's how these are the properties where the hardened concrete usually have. Okay, next, coming to individual one, what do you mean high strength concrete? Here the maximum grade of concrete is 60 MPa. So where we call it as a high strength concrete. Ardhamotuna? I mean beyond 30 till 25 to 30 MPa we call it as a normal grade of concrete. From 30 MPa to 60 MPa we call it as a high strength concrete. Beyond 60 MPa, MPa nothing but Newton per mm square. Okay, beyond 60 Newton per mm square we call it as an ultra high strength concrete under. Okay, so we use ultra high strength concrete for other applications. Okay, we will discuss that later on. So here the high strength concrete which we are going to use for pre-stressed concrete is till 60 MPa. Okay, so here the minimum grade of concrete for pre-stressed applications are as follows. Here please try to remember this. 30 MPa is for post-tension members, 40 MPa for pretension members. Very, very, very important. Okay, understand? So 30 MPa should be the concrete strength when you go for post tensioning. Okay, 40 MPa is the strength for pre-tensioning. Okay, please try to remind this. Okay, please try to keep in your mind. Okay, so these are very, very important. This is what the high strength concrete means. Next one, stiffness of concrete. We all know stiffness of concrete is going to be required to estimate the deflection of the member. Why? Because stiffness always leads to deflection, isn't it? So when a member is having a more load carrying capacity or load bearing capacity, that member will have very less deflection, right? So here we are talking stiffness in terms of deflection. So the stiffness is always given by the modulus of elasticity, isn't it? So let me tell you why steel we are using in RCC. Why can't we use copper? Why can't you use aluminum? Why can't you use brass in RCC? Can anyone please answer to my question? Why can't we use other ductile material? Okay, so in RCC, why we are using only steel? Why? Because steel is having more Young's modulus. Steel is having more modulus of elasticity compared with other ductile materials like brass, copper, aluminum, and other kind of alloys. Understand? So the Young's modulus of steel is 2 into 10 power 5 Newton per mm square. Having more Young's modulus will have very less deflection. Very less deflection will have more stiffness. Ardhamotunda? So having more stiffness, it will have very less deflection. Stiffness ekku undali ante that member should have more Young's modulus. That member should have more modulus of elasticity. Okay, that is the reason why we are using steel into concrete, where it will have more stiffness. Okay, more carrying capacity with less deflection. Understand? So that is what the hardened concrete should have a property in terms of stiffness. And next one, durability of concrete. Okay, so here durability of concrete is also very, very important. So durability of concrete is something like, showing a vital importance regarding the life cycle cost of a structure. Okay, see, because when you go for pre-stressing, you can't erect or you can't construct the structure just for 10 to 20 years. You should build structure for at least for 100 years of its lifetime. Okay, so that durability will always plays a vital importance towards the life cycle cost of the structure. Okay, if you are spending crores of money on a structure, okay, and designing that structure for very limited lifetime, so there is no use. Okay, so your life cycle cost is always depends on the durability of the structure. Okay, and the life cycle cost, which includes not only the initial cost, it includes the material, it includes labor, it includes maintenance, and it includes repairs also. Understand? Durability ante kevalam dani yoka life cycle cost okate మనం చెప్పకూడదు. లైఫ్ సైకిల్ కాస్ట్ అంటే which includes all parameters which are there for the construction of that particular structure, in terms of material, in terms of labor, in terms of maintenance, and in terms of repair. Ardhamotna, please try to highlight this: material, labor, maintenance, and repair. So these four are very important in terms of increasing the durability of the concrete. Okay, good materials will always add on concrete durability. Good labor, good maintenance, good quality. Okay, so good repairs works of a particular some kind of what we call cracks, or some kind of repairs. So you should have a proper maintenance to that, not to increase beyond the threshold limit. Okay, in that way durability of concrete is very, very important. Okay, so which is one of the property of hardened concrete. And next one, creep of concrete. So this is also very important, because creep is a time dependent one, so which is going to be defined as a increasing deformation with respect to time. Ardhamotunda? So that is how creep of concrete is also very, very important. So due to the creep of concrete, what happens? Prestress in the tendon, or whatever the wire we are using for prestressing, is going to be reduced with the time. Ardhamotunda? Eppudaithe concrete ki a creep అనేది తక్కువ ఉంటుందో, obviously it will reduce the tensile strength in that particular tendon, which always reduce the strength in the concrete member also. Okay, అందువల్ల concrete కి creep బాగుండాలన్నమాట. Okay, so hence this study is going to be used in, and which is very important in prestressed concrete, to calculate the loss in prestress. So prestress law, in the second unit, when we start our second module, in that second module, the first content itself is the losses in prestress. Okay, in that we can able to understand very keenly what is the importance of creep of concrete, right? So that is how creep plays a vital role. So concrete should have a very good creep. Okay, so then the concrete can able to withstand the loads, and can add on to prestressing of that particular tendon to keep that for a lifetime. Okay, the creep occurs due to two causes. Creep eppudu vastundo telusa? One, which is rearrangement of hydrated cement paste, especially the layered products. Okay, layered products ante when you are casting a member in an add-on portion, single unit ga kaakunda ఒక్కొక్క దాన్ని ఇండివిజువల్ గా చేసి జాయిన్ చేస్తాం చూసారా, అలాంటి మెంబర్స్ కి క్రీప్ అనేది తక్కువగా ఉంటుంది. ఓకే, సో ద క్రీప్ అకర్స్ because of one reason, where you are going to cast elements individually. Okay, instead of casting a single unit, when you are casting individually and making the unit, అలాంటి వల్ల క్రీప్ అనేది తగ్గుతుంది. And next one, expulsion of water from voids under load. Whenever member is subjected to load, so when there is an expulsion of water from voids, so then also the creep may cause. Okay, the creep causes due to that reason also. Okay, so these are the two important things where the creep plays a vital role in terms of a hardened concrete. Okay, so that you need to keep it in mind. So when you are designing, so obviously when you go for high grade concretes, so with undoubtedly the creep and shrinkage of concrete will get reduced. That's the reason why we are using high grade concretes in terms of creep and shrinkage also. Okay, so next one is shrinkage. What do you mean shrinkage? We all know shrinkage and enti contract avadam, avuna? So you can see these kind of shrinkages in when element which was casted with a huge surface area. Can you tell me one example of an element which is going to be casted in a huge surface area? ఒక పెద్ద సర్ఫేస్ ఏరియాగా మనం క్యాస్ట్ చేసే ఎలిమెంట్ ఏదన్నా ఒకటి చెప్పండి in a building, which is slab. So you can find a lot of shrinkage in slab. Why? Because slab was casted with a huge surface area, right? So when you cast an elements in such a way that which is having a huge surface area, there will be a huge loss of moisture, which is going to contract the concrete. అందువల్ల మీరు ఎప్పుడైనా స్లాబ్స్ క్యాస్ట్ చేసినప్పుడు చూడండి, ఆఫ్టర్ కాస్టింగ్ when you see the next day, you find the cracks కదా, ఎయిర్ క్రాక్స్ లాగా కనిపిస్తాయి స్లాబ్ మీద అక్కడక్కడ. ఆ cracks ఏం చేస్తుంది తెలుసా, when you are not having a proper maintenance of the cracks, that cracks leads to leakage. చాలా మంది ఇళ్లలో స్లాబ్స్ నుంచి వాటర్ లీకేజ్ అవుతుంటుంది when the due course of time. ఎందుకు లీక్ అవుతుంటుంది తెలుసా, దే ఆర్ నాట్ బాదర్డ్ అబౌట్ ద shrinkage of concrete at the time of casting. కాస్టింగ్ చేసేటప్పుడు ఈ shrinkage మీరు మైండ్ లో పెట్టుకోలేదు అనుకోండి, ఆ క్రాక్స్ ఏమవుతుందంటే దే విల్ గెట్ లార్జ్ and it will allow water into it, where the biggest disadvantage is it will make steel corrode and it will create lot of dampness, and there it starts with leakages. అర్థమవుతుందా? That's why shrinkage is very very important for a element which is having a huge surface areas. Okay, so అందువల్ల when we are casting like kind of slabs and all, you need to take care of shrinkage of concrete, so which is going to be defined as a contraction due to loss of moisture. Okay, so ఎందుకంటే huge surface area ఏంటి, it always exposed to sun, exposed to weather. ఎక్కువ ఎక్స్పోజ్ అయినప్పుడు ఏమవుతుందంటే there is a huge loss of moisture takes place, which makes concrete to contract and it creates cracks in it. అర్థమవుతుందా? So that is what you have to understand very clearly. And the study of this shrinkage is also very important in prestressed concrete to calculate the loss in prestress. Prestress లో shrinkage loss కూడా ఉంటుందన్నమాట. Okay, so the shrinkage loss is going to be happen due to two cases. First one is loss of water from voids. Voids నుంచి వాటర్ ఎక్స్పెల్ అయిపోవడం వల్ల ఒక shrinkage జరుగుతుంది. Next one is reduction of volume due to carbonation. Okay, so reduction of volume due to carbonation, because carbonation in terms of casting concrete, so there will be a reduction of volume takes place. So because of this carbonation jarutundi anamata, epudaithe when it is exposed to weather, due to this carbonation only, there is a possibility of corrosion of concrete also takes place, right? So these are the two important causes where the shrinkage of concrete leads to hardening of the concrete is very important, right? So these are very important where the hardened concrete properties, right? So I think you all understood what exactly the concrete and what are the hardened concrete and what are the parameters to be focused in the hardened concrete, right? Next one is grouting. Okay, so before talking about grout and the other materials, let me show you one video. Based on that video, we will talk about other materials which are going to be used for prestressing. Okay, a small video here. See, please try to, I think you won't able to understand his language. Why? Because his language is, it's a foreign language. Please try to focus on the materials which are going to be used for post tensioning over here. Okay, so the post tensioning of girders anamata. He's just showing the na cursor ni observe cheyandama. In this cursor, this is called sheathing, this is called anchorage cone, this is called a bearing plate, and this is called wedge, this is called strand. అర్థమవుతుందా? అలా డిఫరెంట్ మెటీరియల్స్ ఉంటాయన్నమాట పోస్ట్ టెన్షనింగ్ లో. నాట్ ఓన్లీ ఇన్ పోస్ట్ టెన్షనింగ్, ఈవెన్ ఇన్ ప్రీ టెన్షనింగ్ ఆల్సో ద సేమ్ మెటీరియల్స్ ఆర్ గోయింగ్ టు బి యూస్డ్. ఓకే, సో ప్లీజ్ ట్రై టు జస్ట్ అబ్జర్వ్ ద video. So you can't understand the language, I will try to explain you after completion of this video. Okay, So this is called anchorage cone. Anchorage cone anamata. Okay. And this metal is called bearing plate. This is bearing plate antaru. Okay. So these are called strands. ఎన్ని స్ట్రాండ్స్ మనం ప్లేస్ చేస్తే ఆ సైజ్ బేరింగ్ కోన్ మనం బేరింగ్ ప్లేట్ మనం తీసుకోవాలి. ఓకే. So let's count here how many there 1 3 4 5 6 7 8 9 10 11 12. So this is called 12 hole bearing plate అన్నమాట. Okay, in each hole they will insert strand. So this is what wedge is. What is the purpose of the wedge? So I told you what is the purpose of the wedge. Wedge is going to be useful to hold the strand within the position. Strand ni position lo hold cheyadaniki use avutundi anamata wedge. Okay, and this is strand. Ee strand chudandi, it is not a single rod or single wire. It is made up of winding wires into a strand. Enni wires untayi? ఈ వైర్స్ ఎలా ఉంటాయంటే ఇట్ విల్ బి 3 ply వైర్ ఉంటుంది, లేకపోతే 5 ply వైర్ ఉంటుంది, 7 ply వైర్ ఉంటుంది. ఓకే, సో లైక్ దిస్. సో దాన్ని మనం 7 ply స్ట్రాండ్ అంటారు, లేకపోతే 5 ply స్ట్రాండ్ అంటే 5 వైర్స్ ని వైండ్ చేస్తే దాన్ని స్ట్రాండ్ అంటారు. ఆర్ 7 ply స్ట్రాండ్ అంటారు, 12 ply స్ట్రాండ్ అంటారు, 15 ply స్ట్రాండ్ అంటారు. ఓకే, సో దీస్ ఆర్ ఆల్ యూ కెన్ ఏబుల్ టు సీ వెన్ యూ గో ప్రాక్టికల్లీ. ఓకే, see how many wires they have. 1 2 3 4 5 6 7, center 7. So total this is called 7 ply strand. Chusara, so ikkada 7 wires unnai where we wind it into a strand. By that it is called 7 ply strand antaru. Okay,
او 12 فرد ده في الديزاين الكاميرا اللي احنا شغالين فيه دلوقتي. احنا السيستم اللي احنا شغالين فيه دوت اللي هو الكاميرا سابق الايجاد اللي احنا شغالين عليه بقى. تعمل الكاميرا طبعا هنشوف مراحل تصنيع الكاميرا ان شاء الله بالتفصيل، من اول ان احنا نبتدي الشيز بنعمله، بنعمل الكاسات اللي بنحطها بنركبها، بنعمل الشاسيه، وبعد كده مرحله الصب ان شاء الله الشد. دوت دوت الاكسسوارز المبدئيه اللي احنا هنشتغل بيها ان شاء الله، وان شاء الله اشوفكم في التحدي.
okay, yeah, that's it. So now let's go back to our presentation. Okay, so yeah, so let me show you another video, so where it will give more information towards grouting and all. So with that we can continue. Yeah, a very small video, okay, because we are having enough time, so just watch this video, so by that we can go with the presentation.
Center of Iran. The total length of Anchorage is 6 kilometers. The double length is the single length width is 11 meters, and the total span is 44 meters. It's a multi-span structure of prestressed concrete box girder with constant tension, and there are 4 kinds of spans, which are 44 meters, 41 meters, 47 meters, and the main bridge will be constructed span by span, span segmental method, erected by launching gantry from Pier WS-N5 to Pier M112. Only 4 gantries will be used for deck erection, in which 2 of them will start work from Pier WS.
Here you can observe each segment is pre-tensioned. Okay, after launching every segment, Finally, they do post tension. Okay, so here both the stressing systems was applicable: pre-tensioning of individual segment and post tensioning of the whole length of the segments. Okay.
And 5, M1, and the other two launching gantries will start work from M111 to M112. And all launching gantries will move from both ends to the wind launching ridge. Finally, 111 spans of deck will be erected. External cable. OEM external cable used in this project consists of 19 by 50.24 millimeter bare strand, whose elastic modulus is EP 1.95 by 105 megapascal, and the standard strain is FPK equals 1860 megapascal. The Anchorage type is OEM .T15 to 19. The brown pipe type, the external cable is shaped with HDPE pipe in which cement grouting can be filled, and HDPE pipes will be connected by HDPE couplers. 18 external cable bundles are designed in each span, in which 2 cables are reserved. Another 16 cables will be installed and stressed while segments are being wrapped. Total 3,552 external cables, weighing approximately 3,000 tons, are applied to solid bridge. Preparation for external cable installation. Set up a temporary platform for installing and stressing external cables. Then coils of bare strands onto the deck of launching gantry. Put the coils into the coiler and get ready for strand pushing. Put the strand pusher in front of the forwarding direction of launching gantry. Install a curved steel tube auxiliary support. Installation of HDPE pipe. When segments of a single span are erected, welding of HDPE pipes should be carried out at the same time. Assembly of all segments. Install the HDPE pipes in the box girder. A piece of HDPE pipe should be welded with HDPE binder first, then put through the bearing blade and connected to the other HDPE pipes with HDPE coupler. Installation of strand. Connect the curved steel tube to strand pusher. Pull up the head of strand from the coil, then running in the duct. Put the strand pusher in front of external cable, which to be installed. Fix a casing guide to the head of strand. Start the strand pusher until the head of strand comes out from the other end of external cable. Cut off the strand with fuel cutter at the mark point. Multi-strand stressing. Multi-strand jacks are used for multi-strand stressing. Anchor head, jack, dual anchor shall be installed in such a manner that fit tightly with shafts. The external cable should be stressed from both ends synchronously. The tensioning procedure is 0 to 50% delta control, to 30% delta control, 100% delta control. Set anchor after holding load for 2 minutes. After stressing, remove temporary hanger rods of segments and move the launching gantry forward to the next span. Then prepare for grouting of external cables. Duct grouting. Use a portable cutter to cut off the excessive strand out of anchor head at both ends of external cable. Only 30 millimeters long strand will be left out of anchor head. Spray a thin layer of grease on the inner surface of protection cap, then install the cap. Clean out the grouting holes of anchor plates. Connect grouting machine, hoses, and other components needed for grouting. High-speed mixer and UV3 grouting pump are used for duct grouting. It is preferred to grout the upper duct first. installation for one span is finished.
Okay, so that is how stages of stressing and grouting is going to be done. So finally, at the end of the system, you have seen how the grouting was done with the help of a cement paste, cement slurry. Okay, so they add some admixture into that, and they will try to fill the HDPE pipe, which we call it as the duct or sheathing. So with the help of a grouting material. So here grout is something like a mixture of water, cement, and optional materials like sand they use, and they will add water reducing admixtures also into it, and some kind of expansion agents. Okay, and pozzolanas are going to be added in the grout. Okay, so here the water to cement ratio is around 0.5 they maintain, and the fine sand is going to be used to avoid segregation. Okay, so when you are not adding sand into the cement paste, what happens? So definitely, so there will be a lot of segregation takes place. To reduce the segregation and to avoid the segregation, they will add fine sand into the cement grout. Okay, so this is how grouting is going to be done. So because that is also one of the material. Okay, so right, this is what after grouting you can see the cement paste is going to be filled in the HDPE pipe completely. Okay, and what is the next one? Desirable properties of the grout. Here grout should have these properties. Okay, grout and grout should have these kind of properties. One is fluidity. It should be in a position to flow from one end to other end freely. అంతేగాని టైట్ గా ఉందనుకోండి ఏమవుతుంది, it is not having good workability. The fluid can't flow from one end to other end. Okay, it should have good fluidity property. And next one, minimum bleeding and segregation. And third one, low shrinkage. Fourth one, adequate strength after hardening, and no determinantal compounds, and durable. Okay, that's a grout material should be durable. So like this, these are the properties there to be for the grouting material, right? And next one, prestressing steel. So we already talked about. So we are going to use a high strength steel for pretensioning. Why? Because it should able to stress, okay, beyond its yield point, where it can able to sustain up to its maximum ultimate load. Then only that pulling the strands makes your concrete to squeeze it off, right? So that is how the development of prestressing concrete was going to be influenced by invention of high strength steel into it. Okay, the high strength steel in the sense it can be an alloy of iron, it can be a carbon, it can be a manganese, and the optional materials which are going to be added into steel to make steel as a high strength steel. Okay, so in addition to prestressing steel, conventional non-prestressed reinforcement is going to be used for flexural capacity, shear capacity, temperature, and shrinkage reinforcement. As I already told you, along with the prestressing material, there will be some reinforcing materials within the segment or within the girder or within the beam. That reinforcement is only to make that into a shape. At the same time, it is going to be used for a flexural capacity and shear capacity also. Okay, even in the girders and beam, you will have a reinforcement. Okay, you will have a rebarring. That reinforcement is going to be like a flexural reinforcement ఉంటుంది దాంట్లో, shear capacity reinforcement కూడా ఉంటుంది. Okay, so that is how the prestressing steel is going to be used. Okay, that steel will be used in terms of wires anamata. Okay, as we discussed, there are wires which are going to be wind together. We will make it as a strand. Okay, so here each wire is having a different diameters anamata. Okay, the prestressing wire is going to be a single unit which is made up of steel. So the nominal diameters of the wires are going to be like this: 2.5 mm wire ఉంటుంది, 3 mm wire ఉంటుంది, 4 mm wire ఉంటుంది, 5 mm wire ఉంటుంది, 7 mm, 8 mm, like this. Each wire is with these dimensions. అలా ఒక వైర్ కాస్త 5 wires తో వైండ్ చేసాం అనుకోండి, we call it as a strand. Okay, that is called 5 ply strand. అంటే each ply will have a nominal diameter like 2.5 mm, 3 mm, 4 mm, like that. Okay, so in that way wires are going to have a different dimensions. The different types of wires are going to be followed. Here you are going to use a plain wire. Actually, మీకు reinforcement rod చూస్తే in RCC the reinforcement rod will be something like a threaded rod కదా, దానిపైన థ్రెడ్డింగ్ ఉంటుంది. ఎందుకు? టు హ్యావ్ ఎ గుడ్ బాండ్ బిట్వీన్ కాంక్రీట్ అండ్ స్టీల్. సో దట్ ఈస్ ద రీజన్ వై యువర్ reinforcement will have that kind of spiral on the circumference. కానీ ఇక్కడ వైర్ కి అలాంటి you don't need any kind of threading like that. Why? Because here wire is not going to be contact with the concrete within the beam or a segment or a girder. Okay, so that's why wire can be a plain. Okay, plain surface unte chalu, no indentations on the surface should be there. And intended wire, they are circular or elliptical intended wires on the surface. Okay, so that is how you are going to use these kind of wires for post tensioning particularly. Okay, and next one, strand. So what do you mean strand? Multiplying all wires. Okay, binding all wires, we have a strand. So here the few wires are spun together. Spun ante enti wound cheyadam. Okay, bind cheyadam is in helical form to form a prestressing strand. Okay, there are the different types of strands available. 2 wire strand untundi, 3 wire strand untundi, 5 wire strand untundi, 7 wire strand untundi, which I discussed earlier. Okay, in the video also you have seen 7 ply strand. So that is what strands are going to be defined. And next one is tendon. What do you mean tendon? Group of strands or wires are going to be placed together to form a prestressing tendon. Okay, here the tendons are used in post-tensioned members anamata. In a pre-tension member, there is no tendon. There will be only a strand work untundi. Okay, all strands together we call it as a tendon, right? So that tendon you can see only in post-tensioning. Okay, in that we choose a group of strands in a one chamber. In that we call it as a tendon. Okay, so which are going to be used for post tension, right? And what do you mean cable? Group of tendons for a prestressing cable are going to be called as a cable another. But here cables are not going to be used for bridges or beams or girders or for these elements. We are going to use for cables of cable stayed bridges. Okay, suspension bridges. In that we are going to use group of tendons which are going to be called as a cable, prestressing cable underwater. Okay, at there you are going to use these kind of cables, right? So next one is bar. As we already know, what do you mean bar? Bar is nothing but reinforcing rod which you are going to use in your RCC. RCC lo use chese rod bar yokka sizes enti? You will have a 10 mm, 12 mm, 16 mm, 20 mm, 22, 25, 28, 32. Like that, you are having different diameters of the reinforcement rod which you are going to use in making that beam or a girder in a different shape. Rectangular shape kavalana, I shape kavalana, T shape kavalana. A shape manam teeskuni ravali ante your reinforcement should be winded in such a way that then only you can able to cast your concrete in that defined shape anamata. Okay, so this is what the general reinforcement diameter is. Okay, so now you can see the difference between the reinforcement rod. This is the reinforcement rod which you are using in RCC, and this is called a strand. Okay, how many plies you are having here? It is having 7 ply. That's why it is called a 7 ply strand. Okay, so what is this? This is called a tendon. Why? Because they are group of strands added together. Why? Because this is called as a tendon. So that is how. See, not only 7, there are different plies of strands will be available. Okay, so that is how the materials are going to be classified, right? So that's it, guys. This is what about the materials of prestressing, right? I hope you all understand and you are related everything with the videos and images which I have shown in the presentation, right? So that's it. This is the end of the lecture 5, and we have 4 minutes time. If you have any doubts, you can ask me now, right? Any doubts? Guys, please, we have only 4 minutes time. So in that 4 minutes, I will take 2 minutes for the doubt clarification. Then you can shift to the 4th hour. Okay. Please. Is that clear to everyone? One question. No doubts. See, you are telling no doubts. See, at some part, I'm very happy. Why? Because no doubts means I think you got a good information from these classes. But I don't think without doubts there won't be any class, right? So you should ask me doubts. So I don't think you understood 100% from the presentation. So they should have a few doubts, right? So any doubts you can ask me, guys. So there are around 30 students. I think 31 is attendance today. Good. Please, you can unmute yourself and you can ask me questions. Please. So I'm very much interested to clarify your doubts, guys, if you have any. Anyone with the doubts? No one? At least one can speak out and one last minute, 1 minute left. Mithun, anyone else? Any doubts? No one, sir. Okay. So what about others? See, Harini, what happened? Harini, you are not asking any doubts. Anusha, Hindu, Pravalika, where are they? Why you are not asking any doubts? Lavanya, Nikita, Rajesh, Rashekar, Gopi, Naveen, Gandikota, Sarojini, Pawani Kishore. No doubts, huh? Are you clear? Rudviraj? Clear, sir. Okay. Okay, then Mithun. Okay, then that's it. So then we'll meet on Monday. Okay, so where we are going to start the last topic in the first module. By that we can end up with the first unit. Okay, see, after completion of the first unit, I'm going to share few assignment questions to you. You have to answer them. Okay, you have to answer and you have to send me in a form of in a scanned document. Okay, you have to write those theoretical questions. Okay, you have to send me through scan copy. Okay, so for every assignment there will be 1 week time. So from now onwards assignments will be there for every unit. Okay, so in that way we are going to give unit assignment questions in the next class. Okay, while completing the first module. Okay, then I think it's time up. Okay, so we'll meet you on Monday. Happy and stay safe, guys. Okay, thank you.